You can see there seems to be some movement with the well, it could be algae or something fire at the moment, I won't know until it develops. But I've just come down here and I've just got this here, and I'm still none the wiser about making the perfect popcorn. It does seem to be better if you put the kernels in the freezer before you do them. So I'm just sort of adding these in here to yeah, it's a slow process, I know. The initial experiments always are the slow ones, aren't they? So but the newspaper madness under the Sarracenia pot seems to be quite good actually. So and it does seem that you need a full newspaper to get the best effect, I think. So, you know, it seems the thicker the better. Whether because then there's a bit of sponginess in the wet newspaper, and it then presses down and sort of gives us semi-seal to the what is it, 2 to 3 inch slot at the bottom. I don't know, but it does seem to be better. The more the better. But anyway, so we'll keep doing this, and I'll keep making up popcorn until I filled up half the container. Okay, so it'll be half charcoal roughly and half popcorn, and then we might see some action over the next few days as the popcorn, well, it gets saturated almost straight away. Actually, it's very good at water absorption, and then starts to degrade. The various breakdown products of the complex carbohydrates go down to the bottom, react with the charcoal, producing reductive flammable gas, which goes up and hopefully will keep the popcorn in a somewhat stable state. I have noticed from the ones over there, it seems to be able to absorb some of the gas to a certain degree. Whether this explains the often touted anecdote from the literature about that fresh peat has some amazing growth properties, but as soon as you dry it out, two things happen. Is one, it becomes extremely hard to re-wet, and two, it seems to lose this amazing growth potential from true peat bogs, you know. So whether that's because the actual peat somehow retains some reductive flammable gas in its within its structure, sort of thing, and once you let it dry out, that just dissipates and disappears, and of course doesn't come back when you re-wet it, when you eventually do re-wet it, sort of thing. But anyway, I suppose we're going to find out with these experiments. We might discover something pretty amazing. Well, we've already made some sort of thing. You can get a reaction with just pure charcoal. Well, in quotes, pure. I mean, charcoal is never totally pure. It is a source for various minerals, if you look it up. But it is a slow source, to a certain extent. So it's like adding slow release fertilizer in a way. But it does have another amazing property, which I don't think I've mentioned, but I discovered many years ago. When was that? That was in the 90s I made that discovery, so that will be mentioned in my thesis. But yeah, so as I said, charcoal has some properties unique to itself. I think what was it, Rosalind? Oh, I've forgotten her name now. She also showed there are different forms of charcoal. So, you know, charcoal isn't just charcoal. There are different forms of charcoal, which might surprise some people. Yes. Anyway, Rosalind Franklin. Yes, the famous Rosalind Franklin. She did a lot of work on charcoal before she did the work that she's most famous for. And she made that discovery that there are different forms of charcoal. So, there you go. So, charcoal ain't charcoal. Oils ain't oils, as they say. So, as we know now these days, oils ain't oils. But anyway, I'll keep doing this, and the next clip you'll probably see when it's totally filled up, and we'll see what it looks like, and we'll go from there, sort of thing. Okay, over and out.